Okay, you guys, solving systems of equations. The goal is to solve systems of linear equations of two equations, two unknowns, using either substitution or elimination. So let me remind you how to do that. Let's solve the following equation. Let's solve the following system of equations using the substitution method. We've got x plus y equals 10, and y is equal to x plus 8. So you guys tell me, what do you do if it's the substitution method? You've seen this before.
You add x plus 8 to the first equation. You put x plus 8 in place of y in the first equation.
Okay. So at first you said add, and I thought you were thinking elimination method. So what he's saying is, hey, look at this guy down here. Y equals x plus 8. It's solved for y in terms of x, right? So the idea is, couldn't we substitute the x plus 8 in for y in the first equation, thereby getting the equation down to one variable, getting one equation down to one variable, which we can solve? Does that make sense? So that's the substitution method. Here's what I would do. I would get in the habit, so I'm going to write down x plus y equals 10, except instead of the y, I'm going to put in a set of parentheses. It's a good habit to get into, to write down a set of parentheses in place of the variable you're subbing into. And then in that set of parentheses, I'd plug in the x plus 8. Now, in this particular problem, the parentheses aren't doing anything, right? So you can just drop them and combine like terms. What could you do if you combine like terms? What would you get? 2x plus 8 is equal to 10. And then you go about solving that. What do you do to both sides to solve that guy? So we'll start by subtracting 8 from both sides. What does that get us? 2x equals 2, or x equals
1.
Yeah, divide both sides by 2, and you do get x equals 1. So we're done, right? No. When you solve a system of equations, what's the solution look like if there is a single solution?
It's an ordered pair.
It's an ordered pair, x, y, right? It would represent the intersection point. If there's a single solution, it's an intersection point of the graph of the two lines in the system given. Okay, so I've got the first coordinate of the solution. I need the second coordinate. I need y. What would be the easiest way to get y? Yeah, so if you plug in 1 for x in the second equation, y equals x plus 8, just add it, and you're done. You've got your y. So you get y is equal to 1 plus 8. I suppose you could have put in the parentheses there, but in that case, I don't think it's all that necessary. And you get y equals 9. So how are you going to write the final answer? Yeah. Parenthesis 1 comma 9. And this point represents, so if you were to graph these two lines, these two equations, they'd be lines, and their intersection point would be 1, 9. Isn't that way easier than the method I showed you yesterday by graphing? Yeah, it sure is. Part B, same direction, solve using substitution. It's not quite as easy. We've got x minus y equals 5, x plus 2y equals 7. Now, in the last problem, we had y by itself on one side, right? So that made it really obvious what to substitute. But there often is an easier way to do a problem, to approach a problem. So the idea in the substitution method is to get one variable by itself and then sub in whatever the right-hand side is into the other equation, into that variable. So let's start. First things first, what variable would be easiest to solve for, and in which equation? Would it be easier to solve for x or for y? Would it be easier to get x by itself or y by itself? X. And in fact, I would choose the first equation, because if you choose the first equation to get x by itself, all you're really doing is what to both sides? You could add y to both sides, couldn't you? I'll actually show that, though. So let me go ahead and rewrite the first equation. X minus y equals 5. I'm solving for x, so you guys told me, hey, add y to both sides. And what does that give me? X equals
Y plus 5.
Y plus 5. And then what am I going to do with that y plus 5? Substitute it in for x in the first equation or the second equation? If you plug it in the first equation, you're just going to get a true statement and it won't help you. You've got to substitute y plus 5 in for x in the equation you haven't touched yet. Now, it is a good habit when you're plugging in quantities. So I'm going to replace this x right here with a set of parentheses. It's a good habit to get into. And then in that set of parentheses, everything else stays the same. In that set of parentheses, plug in the y plus 5. Now, this is another case where the parentheses aren't doing a thing. You can just drop them. But don't worry, I'll show you why we remember to put them in later on, because when it comes to more complicated equations, it's helpful to have those parentheses there, to not forget them. So you can drop them, combine like terms. What do you get? How many y's? Y plus 5 plus 2y equals 7. So 3y altogether, and then plus 5 equals 7. Okay, so we'll go ahead and subtract 5 from both sides. We've got 3y plus 5 equals 7. You guys are telling me, hey, subtract 5 from both sides. Get 3y by itself first. So we do that. What do we get? 3y is equal to? 3y equals 2, and then y is going to equal 2/3 if you divide both sides by 3. Does everybody buy that? Okay. So we're done, right? No. We've only got one coordinate of the solution. So how do we get the other coordinate? How do we get the x coordinate?
Go back to the first one and plug y in.
Yeah, but there's an easier equation to plug y into. So 2/3, we want to plug that in somewhere, right? Now we could plug it in here. We could plug it in here, but there's an easier one down a little further. This guy is already solved for x. So why not plug it in there? Does everybody see that? You want to make your life as easy. My goal is to make math as easy for you as I can. And so plug it in the one that's already solved for x. That'll make life easy. So you get x is equal to, okay, 2/3 is where the y was, plus 5. So that's 5 and 2/3, right? Usually in this class, we're going to leave answers in terms of improper fractions. So if you got a common denominator, think of this as 5/1. What's the LCD? So just multiply by 3/3. And yeah, there's a shortcut for that, I know. But it doesn't hurt to review once in a while. So you get what? 2/3?
17/3.
Plus 15/3, which is 17/3. You're exactly right. So how do you write the answer?
17/3.
Yeah, the first coordinate, the first coordinate is 17/3. The second coordinate is 2/3. Can you check your answers on these kind of problems? Yeah, is it fun to do when the answer is in terms of fractions?
No.
It is if you know how to use your calculator. This is a good opportunity for me to show you how to make your life easy using a calculator. If you look at the original set of equations, I need to scroll back up here. There's the original set of equations. We're saying 17/3 and 2/3 are the solutions. 17/3 and 2/3 are the solutions. So if I take, x minus y equals 5. Now, I guess I don't really need a calculator for this one, do I? But just in case you get more difficult answers to work with, here's how you'd use the calculator. So I could take the calculator and I could type in, okay, in for x, I could type in 17/3, in for y, 2/3. So I'm taking 17/3 minus 2/3. Is that going to equal 5? Well, it's 15/3. Is 15/3 5? Yeah. You bet. But I mean, you can imagine if the decimals were more difficult to work with, if you didn't have common denominators, this would be a great way to check your answers. So you do get 5. Press enter, get 5. And then, okay, and then x plus 2y. Okay, so that would be 17/3 plus 2 times 2/3. Right? plug it into the second equation, x plus 2y, that better equals 7, right? And, of course, it does.